So this was the 150 here, yes?
Yeah.
155, 60, 65, 70, 75, 80, 85, 90. I don't have to worry about an average right now because we're not using averages. Matter of fact, all I've got to do is slap up my two fences, if you will. Anything outside of those are going to be too small or too big. So my big fence was 201.25, okay? No problem. 201.25, I didn't have any guesses over 200 pounds. So nobody guessed too large. But going back to what Carly said, the 190's okay. It's the biggest guess, but it wasn't unusually big. It was just the biggest data point. That happens. Every data set has a biggest value, right? That doesn't mean it's too big to be considered typical. How about the 150? Is that too small?
Yeah.
Yes.
According to this, it is. Because our low fence cutoff is down here at 151 and 0.25 pounds. Now we can get in a fist fight about this too if you want. We can get in a fist fight, we could force this to be rounded to 150 and force that to be rounded to 200. And I would be totally fine with that argument. Same argument we had before, right? Alan, the same rounding argument? You can totally do that, that's totally fine. But it seems like you guys want to have an outlier. So there it is, if you want to go purely mathematically. If you want to go more precision-wise, call that 150 and say, yeah, 150 is okay too, because it's not too small, it's right at the end. David's like, I like that answer better. Then go with that answer. This is not going to be a correct, wrong, it won't be a right or wrong, all right, all wrong. It's however you choose to attack it. If you choose to attack this with standard deviations because you think it's bell-shaped enough, you might get different results for the exact same reason. Fair? Maybe that's not fair. Believable. The word fair is tough. It's not really fair, it's statistics. Believable. I saw a hand, I thought. Please, Veronica, yes.
So when you say it's okay to round that 151, is it because we went by 5 pounds?
That's what David was getting worked up back there. And, well, I think the original data was not accurate to the nearest tenth of a pound. I said approximate my weight. First of all, approximate my weight, not measure it, approximate it to the nearest 5 pounds. So technically, the precision of 1.25 pounds is a little bit facetious.
Because we want them to match.
Technically speaking, your precision, I think your precision should match. It should be no more precise than your least precise measure.
Yeah.
So, I know, Joe's like, what the hell? Chemistry class. Is it working out?
Well,
Hold that thought, Joe, hold that thought, please. Give me 30 seconds. Linda?
So if I understand correctly, 151.25 is the outlier, and that's because, well,
That's the fence that separates too small from typical.
so 150.
That becomes the outlier based off of 151.25. 190 is fine because he's left of 200.
Gotcha.
Fair enough? Joe, go.
okay, I know we're dealing with two separate tools.
We are.
Okay, but I just ran the standard deviation.
Good for you!
2 standard deviations in a bell curve, and it's within 0.5.
Is that everything's good in that case?
Yeah.
So in other words, 150, if they agree fairly well, you might be able to reverse argue that it was bell-shaped enough. And that's why I'm saying it's full of gray. You pick the one you want to use with a justification as to why you use it. It's a stat class. It's not a math class. It's a stat class. I mean, that's what I hate about math classes. They force you guys into this little trough. Solve x squared. Take the square root. No, pick which one you want to use.
But if your mind works that way.
I'm going to unlearn you like yoga. Go, Pat.
Okay, I'm
Learn at your room.
not trying to be a dick, and this may be an irrelevant question, but okay, that's the method and
Yes.
the steps. My question is why? Why do we care?
Can you give me 5 minutes on that? I've got at least a half a dozen reasons as to why you should care. If I may share them with you. I've been collecting them over the past few years, and this is the best question of the day. Okay, this is great, an hour and a half later.
Yeah.
Why do we care about outliers? Give me 5 minutes.
Okay.
That's all I ask, 5 minutes, thank you. Best question of the day so far. Please,
But really, it depends on the objective, on what you're wanting to get out of the information.
4.5 minutes. No, seriously, it's tied to that question. Because they can imply different things. And I think I've got enough, I've been collecting these for, like I said, 15 years of data that I want to share with you guys because of that. Yes, yes.
So if you were, say, writing a paper, I would say within a typical data range, is that how you just use it?
And most of the time, you're looking for outliers because you're looking for things that have changed. How many of you guys have read like psych journals or soc journals or HDFS journals with p-values? P less than 5%, p less than 5%. Those are outliers. Outliers imply something is different, that a medication is working, or a treatment is not working, or that ages are the same, or that ages are different, or the weight has been lost, or the weight has been gained, or the weight has not changed at all. That's what's identifying as the outliers.
Okay.
Hold that thought too, 4 minutes. Yeah, good. Please.
Question about the fences.
Yes!
What if somebody guessed 151,
Hey, check this out. Check this out. You ready? This is annoying. It is. It is highly annoying. I trust you. So turn your TIs back on. The standard deviation calculation is a piece of cake. Double it, add it to the average, factor the average, done. This one is very, very steppy, and it's not exactly logical. Thank God. You don't have to do it by hand because your TI will do it for you automatically.
Yay.
Watch this. You already have your histogram on, yes? You've got your histogram on. Turn a second plot on with it, a box plot. But make sure it's modified. Watch this. Second y equals, leave plot 1 on. He's good. Plot 1 is fine, leave him on. Switch down to plot 2, turn him on, but pick the modified box plot, which will automatically show you outliers, if they exist. And the method it uses to plot them is this. It does this math for you automatically. Rather than making you go through all this times 1.5 plus this minus this, it just drops them up there for you. And now make sure your X list and your frequencies match. Make sure it's L1, L2, just like it was for the histogram. Oh, you have to go right, Ariel, not down. It won't let you go down for some reason.
Yeah.
You have to go, you have to go to the right and then wrap around. I don't know.
Oh, okay.
I blame it all on 1985. Great year, but that's when these damn things were made, and they haven't changed since. Once you got that, just press graph. There it is. There it is, right there. The window's a little bit small, so it's cutting it off. It's the actual screen. But there's your outlier. Everything else, typical.
What's that other dot?
This guy right here,
No.
that's probably banana.
Would you say the window should be at?
There we go. Probably a piece of banana. But, oh, I changed it to 150 to 195. You can also just press zoom 9. That'll get you the window too. There you go, right there. The reason I don't like this is because now the box spot's sitting on top of stuff, and I like to mess with it so it's separate. A little too German for my own good sometimes. See, I can't leave it right now. I gotta change it. And I like this too, because we also see our distance again, Mon. We see the distance between the unusually small data point and the next typical data point. Notice when you press trace and you jump up to the box plot, it identifies things. It identifies this as the min x is 150. Now it just calls that just some random x value. It doesn't call it anything. It doesn't call it Q1 because Q1's there. There's your Q1. But this is no longer a minimum. It's just the smallest typical data point using this procedure. So I guess, oh Linda, go ahead.
I just don't understand what this just did.
It's doing this,
Oh,
so you don't have to. It's going to find them for you out here.
okay.
Or outright if they exist outright, which we don't have any that exist outright in this data set. There aren't any that are too big by this method. Fair. Fair? That's the right word, right? No, it's not fair. Sensible. You can't really call it fair or not, it's just handed down to us, but sensible and believable. Maybe. We still haven't answered the question of why we give a crap, which I do want to answer. It's a very important to answer that one next. But first of all, Carter, go.
Is there any way to have your calculator actually tell you what the range is? Because that doesn't, unless you have a data point that's at 151.25 or 201.25. Those,
Oh,
do you
so
see what I mean?
graph the fences. So you
Well, not
want it to actually
necessarily
show
graph them.
those on the graph?
Just do the math for you.
It is doing the math for you. It's not giving you the fences that are the result of the math. That you want it to show
Yeah.
that.
How do you find that out?
Well, you have go for this.
Besides that.
You have to, the math has to be done somewhere.
Okay.
The math is being done here in the background, but it's not giving you the fences that you want. You could write a program very easily to slap up 2 vertical lines on the box plot.
Okay.
If you're interested, I'd be happy to sit down and work through it with you. It wouldn't take very long. But that's, unfortunately, the math has to be done somewhere and then reported back. I wrestled with this
But
recently.
there's no like automatic.
No, not the way these are set up. I think Excel would be a much better tool for that, honestly, because but the problem with that is the box plots are a real pain in the butt on Excel. But you could easily have the math program in. You ever need it, let me know. We'll sit down and do it, happily. Joe, go.
So, like I said before, I ran this.
You did?
Standard deviation.
Yes.
It came out to 19.28.
Which
So-
is, that's 2 standard deviations.
Yes. So, realistically, do we care enough to even bother with the math?
I can't answer that question. The thing is I'm giving you 2 tools to cover all the bases. This is the one, number 1 is the one that's predominantly in the research, in the journals. Now, there's a reason for that. You almost always get bell curves in the journals for a reason you'll learn as we go through this course. I keep talking about bell curves, bring them up. There's a reason why I keep doing that. They do show up, and sometimes we can make them show up. Mathematically, properly, not just because we want them, because mathematically we can make them show up. You'll see why with some fuzzy dice that I created in my garage a few years ago. That's that one. But if you're not dealing with one of those bell-shaped data sets, this is a fallback that you can still use. So I wish there was a better answer to that. There's just not. It's just these are the ways to deal with it.
But if you rounded both numbers, you're
They
coming out
won't
at
always
19.
work that way.
That's because this is really close.
This is really close to a bell
Going
curve.
like this,
Exactly.
they'd be so far away from each other.
Let me give you an example without collecting the data. How many texts have you guys sent today? Text messages you sent today up to this point. Okay? 0. Let's see 0. Okay, that's a lion's share of the class. 1, 2, 3, 4, 5, 6, 7, 8, 9. Anybody over 10? You see, guaranteed. Can't be bell-shaped at all because it's exponential. If you get data like that, which, and this is a ridiculous example, yes, but somebody provided an awesome one, and was either this class or their class on the exam, show me an example of statistics that are misleading. They printed out a graph of automobile fatalities by age group, number of fatalities by age group. I don't know who, a couple of you did it, and then somebody else provided a better look at it, looking at percentages of fatalities. Oh, look at that. Come on, hold it up nice and high. This is number of fatalities by age group. Good luck proving that's a bell curve, because it's not. Because it's not. You're missing a whole chunk of it. So this gives you a tool to actually deal with it, although you shouldn't do anything on this anyway because it's misleading. But the point is that those data sets exist. If they exist, you've got method number 2 to deal with. Fair?
Fair.
Doesn't answer the question why we care, but at least it gives you a reason why you have to have a Phillips and a flathead. If that makes sense. If that makes sense. Now, let's talk about why we care. Let's talk about why we care. Okay, sit back and take this in. Hopefully this makes sense.